The best way to get the most of today's session is to relax. Just relax. Stop worrying. That's the greatest achievement. So we're going to follow the same, more or less, format for our review session tonight. We're going to do one of the older exams to go through it, right? At 9 o'clock we're going to have two students coming up again, like the other time, give us a 10-minute break with their talent. Yeah?
Yeah.
All right, so let's start. I'm going to try to use the board. I think it's easier to follow that way with chalk. So let's start. Maybe we should start with multiple choice concepts, or should they start with arithmetic problem? What should we do? How many people run arithmetic problem? Raise your hands first. How many run multiple choice first? Okay. Whatever you want. You're driving.
Looks like arithmetic.
Should we start first with a balancing or no? Okay, let's start with this one. Okay, so this problem is telling us to consider a monoelectronic cation. Addition to plus is a monoelectronic cation, and to calculate the energy in joules of its electron when it is on the first orbit. Not only that, but to find out how many times it is lower or higher compared to the energy of the electron of the hydrogen atom when it is also on its first orbit. Right? Okay, so the problem is talking about the energy of an electron of a monoelectron species. So immediately what comes to mind is the equation that you have at the last page of your exam. You probably remember, it's not that hard to remember it, that the energy on orbit number n, 1, 2, 3, right, is equal to minus RH times ratio of, in general, monoelectronic species. We're not talking about hydrogen, right, in general, with atomic number Z. So it's going to be Z squared divided by n squared. This is the constant atomic number and the first quantum number, right? Or number of the orbit. We shouldn't say first quantum number actually, but it is, right? Because this is the Bohr model, so we have not gone yet to the orbitals for this at this point, right? So it's the number of the orbit, 1, 2, 3, and so on. Atomic number, the constant, and the energy of the electron at that orbit. If it's n is equal to 1, the first orbit, and so on and so forth, right? So the way the problem is talking is we need to find out, as you can see, if we want to find out how many times each one is bigger than the other one, or lower, whatever, we need to find out each one of them, right? and then we can compare them. So for the hydrogen then, for the hydrogen atom with 1 electron, right, we have Z is equal to 1 because it's hydrogen, and therefore this one will give us, okay, the energy of, let's see, hydrogen. The problem is talking about what? When you have the hydrogen, it talks about the electron to be in its first orbit, right? So that means that n is equal to 1. So we're going to have E1 minus RH 1 square atomic number of orbit. They are both 1, right? So that will make minus RH. Okay, we'll do the same thing for the cation of lithium. Lithium has 3 electrons. If you take 2 electrons away, you will have 1 electron left. So they're both monoelectronic species, so we can follow this equation. Right? So Z here is what? If you look at the periodic table, for lithium, Z is equal to 3, right? Now you have to be careful here. Which orbit is talking about for lithium? Is it the first one or the something else?
First.
Also first, right? Could be, it doesn't have to be 1, right? Could be something else. It says the first one again. Okay, so we have E1 again for the lithium now, right? It's going to be minus RH. And it's going to be 3 square divided by n square, 1 square. 3 is the atomic number, 1 is again the first orbit. So that will give us minus 9 RH. Okay, if the problem was saying how many times one is larger or smaller than the other one, we don't have to really do any calculations, all right? Or to put any numbers. We just take the ratio. RH and RH goes away, it's the same number, and we have the answer. But it's actually asking more than one question. It says, calculate energy in joules, and then it tells us how many it is lower or higher compared to the energy of the electron in the hydrogen atom. So if that's the case, then we have to continue, right? We have to continue minus 9 times the constant has the value from the last page of your exam, 2.179 times 10 to minus 18 joules. So that will give you a value of minus 1.96 times 10 to minus 17 joules, right? And to answer another question, you can see this is 9 times more than that. So the answer will be 9 times lower. Right? Correct? That's it. Will we go to the next? Okay, here's the next one. We have an aqueous solution here that is a mixture, has two soluble salts dissolved. Potassium and sodium salts are soluble. All the salts that they have as a cation in the first group from the solubility rules, right, will be on the